Well, hello again, PP2612. Today we're looking empirically at mountains and war, so let's head to higher ground, to my shed roof. So we've looked at some of the theoretical reasons for why mountains might be related to war and conflict, and we found that some of the assumptions about mountains and human behaviour were a little, let's say they were questionable. If we really want to know whether mountains can be related to war, then we need to look at the numbers. So let's look at those numbers right now. The UN Food and Agriculture Organization, the UNFAO, says that conflicts in mountains have increased in the last 50 years, with serious violent conflicts now almost twice as likely to occur at high altitude. Blimey. The World Mountain People Association goes a step further. Because mountain territories are often border zones between states, they are often the scene of many wars or guerrilla warfare. Thus, 80% of the world's conflicts are played out in mountain regions. Wow! Think about that. 80% of the world's conflicts happen in the mountains. If that's true, that's incredible and has clear political implications. There's only one problem with it. There is no evidence to back this claim up. The data, the methods, the sources, they're not there. The same is true of the FAO's claim. There's no data. If I wanted to rerun their analysis to check their data and methods, I can't. One of the points I've been making throughout this course is that without evidence, claims are meaningless. Unless the FAO or the World Mountain People Association provide evidence to the contrary, their claims are without foundation. For all I know, they could have picked those numbers at random. So I'm forced to dismiss their claims. This is where empirical, academic, scientific work on geography and war comes in. So let's look at the academic literature from authors who cite their evidence and describe their methods. Fearon and Leighton tell us that mountainous terrain is significantly related to higher rates of civil war. Well, there we have it then. Case closed. But wait, writing a year later, Collier and Hoffler find that several variables are completely insignificant, among them mountainous terrain. Writing a year after that, Buhaug and Luyala write, "The discrepancy is disturbing." Damn right it is. It can't be both ways. Mountainous terrain is either linked to war or it is not. It can't be both ways. Can it? Well, the answer depends on one key factor. What do we mean by mountain? Here in the UK, we often look to the Ordnance Survey to define what is and is not a mountain. For the OS, prior to the introduction of metric scales, an elevation of 2,000 feet was a requirement for something to be a mountain, although there are some land masses which are considerably less than that, such as Conway Mountain. Interestingly, anything over 2,000 feet in Wales is known as a Hewitt, while in Scotland, a landmass between 2,000 and 2,499 feet is a Graham, one between 2,500 to 2,999 feet is a Corbett, and anything above 3,000 is a Munro. In some ways, this is echoed in Germany, where the highlands are known as Mittelgebirge, the mountains themselves are the Gebirge, and the big ones are called Hochgebirge. To me, one of the most interesting categorizations of mountainous terrain comes from the shepherd tribes of Kyrgyzstan. A Daban is a difficult rocky defile, an Art is very high and dangerous, a Bel is a low easy pass, while a Kutal is a broad opening between low hills. I find these to be among the more useful descriptions for students of war and geography, as they get to our most important concern. How much of an obstacle does this terrain present? In the United States, the Board on Geographic Names was established by the US Geological Survey with the aim of developing a definition of mountain. They looked first to the 2,000 feet standard set by the Ordnance Survey in the UK, and then to their own historical definition of 1,000 feet relative to local terrain, but not sea level. Eventually, they gave up, declaring that broad agreement on such questions is essentially impossible. Now, in the UK, a half-hearted attempt to move to a metric scale was made in the 1970s, and as such, the Ordnance Survey had to revisit what a mountain was. 2,000 feet converts to 609.6 meters, but that's not a very pleasing, round, easy to remember number. So they decided the new definition would be 600 meters, 9.6 meters shorter than the old one. Suddenly, in the eyes of some, a new mountain was born, Black Combe up in Cumbria, 1,969 feet or 600.15 meters. But from our perspective, as students of war and geography, is it really a mountain? How much of an obstacle is it? How difficult is it to get up? Well, we can measure that. An uncle of mine, Ronnie Fisher, was for a while the second fastest person to run up and down Black Combe. So, in the name of better understanding geography and war, I think it's time to follow in his footsteps.
So, my daft uncle Ronnie used to be able to run up Black Combe in 30 minutes and come back down again in 13 minutes. Can I do it as well? I doubt it, but let's find out.
Sorry, my battery ran out at the top. So, Ronnie got up in 30 and down in 13, while I got up in 37 and a half and down in 25 or something. The bottom line here, you can run up and down it in about an hour. Yes, it is an obstacle, but it's not that much of an obstacle. As students of geography and war who want to understand what sort of terrain will have an effect on conflict, should we include it in a list of mountains? My argument is this. For students of geography and war, it's a mistake to even make a list of all the world's mountains. It's a misleading irrelevance. I'm not the first person to say this. Lucien Febvre was saying something similar back in 1925. The division of the surface of the globe into mountains, plains and plateaux is an old and traditional one. Modern geographers have received it from their predecessors and have not abandoned it, which is perhaps a mistake. It certainly is a mistake for modern geographers, and it's more of a mistake for students of geography and war. But there are things we can do to solve the problem. Before I explain what those things are, I need to show you just how much of a problem it is. Earlier, I presented the disturbing discrepancy identified by Buhaug and Luyala. As a reminder, Fearon and Leighton said, mountainous terrain is significantly related to higher rates of civil war. But Collier and Hoffler found several variables are completely insignificant, among them mountainous terrain. They can't both be right. Something's wrong here. To figure out exactly what is wrong, we need to dig into the methodology, specifically the operationalization. While Collier and Hoffler's work was published in 2004, they originally looked at mountains and war in an earlier paper in 2000. For that one, they realized that they themselves couldn't find a way of measuring mountainous terrain, so they asked a mountain expert by the name of John Gerard. This seemed a sensible policy, as Gerard is indeed an expert who came up with a highly detailed definition of mountain. There are 4 parts to his mountain definition. First, it needs to have a minimum elevation of 1,000 meters. Second, deep river valleys can be included if they are part of the mountain area. Third, it must have a relative relief of 500 meters. And fourth, it must have a minimum area of 100 kilometers squared. This solves the Black Combe problem straight away. It's 400 metres below Gerard's first criterion, so it's not a mountain. Indeed, by this definition, there are no mountains in England at all. England's highest point, Scafell Pike, is somewhere between 977 and 979 metres, depending on which source you use. From this, Gerard was able to determine a mountain percentage for each country in the world. France, for example, is 10.5% mountain. But there are three major problems for why this should not be used in studies of geography and war. First, it's based on a mountain binary. Something is a mountain or it is not. I'm not saying that mountain is a false dichotomy. I'm happy to believe that some things should be called mountain while others should not. And you have to draw the line somewhere. But students of geography and war should not use such definitions to understand the relationship between conflict and terrain. Not all mountains are equal. Some present a much more formidable barrier than others. By reducing mountain to a simple yes-no, we're ignoring this. The second problem is this: why measure the percentage of the entire country? If you wanted to look at how mountainous or rugged terrain had affected conflict in, say, Chechnya, you would want to know about how rugged the Caucasus region is. The percentage of Russia which is mountainous would be an irrelevance. The third problem was that Collier and Hoffler asked Gerard to make a list of mountainous percentages for the whole world, but they didn't give him a list of countries, so he made his own list. Gerard is a mountain expert, but he is not a student of geography and war, so he didn't know that researchers of geography and war have standardised lists of states going all the way back to 1816. Essentially, the list he created was a snapshot of the world at one time, based on his own list of countries. Based on the lists of states that students of geography and war use, it had a bunch of entities which we don't consider to be states, and it missed out over 30 that we do. That became a problem. When Fearon and Leighton ran their 2003 analysis, they noticed that those key states were missing. And they were the states in which conflict had occurred, so they needed to find a way of completing the list. They could have gone to John Gerard, but they didn't have the money, so they decided to fill in the gaps themselves. Now, they couldn't do what Gerard did, as it was rather involved, so they came up with their own simplified version based on just looking at the elevation. So they took the dataset created by Gerard and commissioned by Collier and Hoffler, a dataset from which, from the perspective of geography and war, is flawed because it's based on a mountain binary, which includes parts of countries not involved in conflict, and they added data for about 30 states using a completely different methodology. When we go back to where I started, with Fearon and Leighton saying that war is related to mountains, and Collier and Hoffler saying it isn't, are we really surprised that they found these incompatible conclusions? The situation actually got worse in 2009, when Collier and Hoffler, with a new co-author, Rona, made a new analysis which includes those missing states, and they filled in the gaps with Fearon and Leighton's methodologically inconsistent data. If we really want to understand how mountainous or rugged terrain relates to conflict, then we have no option but to disregard all of those findings. So, if we can't use the existing mountain dataset to look at the relationship between mountainous or rugged terrain and war, what can we do? Well, instead of worrying about defining mountains, let's use some real data. This map of the world has been created using something called the NASA SRT-M30 RAMP-2, the Shuttle Radar Topography Mission. NASA flew the space shuttle with a radar on it pointed straight down to Earth. From this, they were able to create an incredibly high-resolution map of the elevation of every part of the world. The dataset is fantastic. Here's a rendering of Africa based on those data, where I have massively exaggerated the elevation. From this, we can create a spectrum of ruggedness, where you can have a territory with an entirely flat topography or an entirely rugged topography and everything in between. So consider these 4 theoretical terrains. Terrain A is lowland, it's flat. Terrain B is a mid-level plateau. It's quite high up, but it's also flat, easy to traverse. Terrain C is a high plateau, also flat. You might get a bit short of breath from the elevation, but it's still easy to traverse. Finally, territory D, the most rugged theoretical terrain, with an endless alternation between sea level and the summit of Everest. For A, B and C, we would give the same value, a ruggedness of 0. But we would give a high value for terrain D. By looking at the NASA data and converting them to meters, we can finally measure ruggedness by looking at the localized elevation variation, using a technique which I call the King's Move. But the ruggedness of what? Countries? No. Conflict zones. In the most abstract form, we can take all of the parts of the world identified by Prio and Uppsala as having experienced recent conflict, measure their ruggedness, and then do the same for all of the parts of the world which have not experienced recent conflict. Then, using more granular data, we can look at a source like ACLED and measure the ruggedness of individual conflict events. When we do this, what do we find? Well, on the top level, it's this. The whole world has a ruggedness of 18.9. The conflict world scores 22.9, while the non-conflict world scores a 16. So there we are. There is a difference. The parts of the world affected by conflict are more rugged than those parts not affected by conflict. Conflict zones are more rugged than the states they're located in. In more rugged states, capital cities are in the less rugged parts of the state. Civil conflicts are in more rugged regions, interstate conflicts are in more rugged regions, state borders are more rugged than the rest of the world, borders within conflict zones are even more rugged, and territorial, extrasystemic and internal conflicts are more intense in rugged regions. So, after all that, we really can say that there is a relationship between mountains, or as I'm going to insist on saying, rugged terrain, and war and human conflict. But we need to be extremely careful in how we measure it.